So this afternoon, we're going to have a chance to participate and hear from the Gather organization, and Suma and her team are ready to participate in that. So, Suma, it's your turn to go.
All right, rock and roll. So, hi everyone. Great to meet you. So, my name is Suma Reddy. I'm the co-founder and CEO of Gather, and I'm joined here by our two engineers, two of our engineers. Ege, you'll see him sharply dressed in a blazer right over there, and then Ahmed is as well. So, any hard technical challenges, please refer to them. And then also two fantastic guest speakers, Corey Mesa from LeGrand High School, if I pronounced that right, and a teacher out there, and then Ray Tyler, who's a farmer who is using our system currently. So sort of the outline of this, we're going to try to keep it short, sweet, tight because we're all busy. And I'll give a probably like 10-minute intro, pass it on to Corey to give his thoughts on why they're choosing a Gather, Ray's experience with the Gather on his farm. And then we may have a student pop in. He's with some in a meeting right now, so he might not be able to make it, but I can share his experience on behalf of him on working on and building the Gather. So yeah, without further ado, just a note, like feel free, you have my email in there, you have my number. So if you don't catch anything, like just reach out to me directly. That is what we are here for. So Gather, our mission is building simplified, versatile, hands-on robotics platforms for schools. I'm an educator myself. I teach a semester, more focused on, entrepreneurship, but really love the education space. Ege started building robots, when he was 12, I believe. So we're really passionate about kind of building this, future of work in agriculture and educating the next generation. So we are a Merced, California-based company, proud to be one, and we build AI-powered robotic tools for schools and farms. So there's us at California Table Grape Commission Demo Day. Um, so what is the Gather platform? We're a robotics platform that aims to empower students to build, develop, and create, and then innovate in the intersection of agriculture and STEM. Our ethos is simplicity. We are trying to make it accessible and even enjoyable to build, use, and develop our system. So four key principles: simple, customizable design, two, compact and portable, three, a curriculum tailored to your backgrounds and needs, and budget friendly relatively to other systems. So we are designed, in our opinion, specifically for high schools. We are working with colleges like the University of Merced and UCANR. But one thing we were excited about is that we've seen high school, middle school students play with our system, and it is easy to them for you. So simple, affordable, accessible. Three key pieces. One, a curriculum for teachers. So in addition, of course, to getting the platform, really kits that enable teaching. We would like to offer Teach the Teachers virtual sessions, and this was suggested to us by a teacher in this group here, Tuli, building the Gather, different education modules as well. Two, you all know the Farm Robotics Academy Challenge, so I won't spend any much time there. And three, we are a young company, and so we are very serious about trying to build a community of educators, administrators, students, right, who can help ensure that this is a success. So not to try to put more work on you, but anyone who does want to become part of this community we're building, we would love to have you. So just to jump into the highlights of each of these. One, the curriculum. Three different modules here: the build side, the develop, and the innovate. And you'll see some students there. So in the build side, it consists of three modules where students build the hardware platforms from scratch. So it's mechanical assembly and drawings, right? Doing the electrical system and harnessing, and then the first power on and diagnostics. So based on our experience, whether or not you have a mechanics background, you can do this. I'm hoping Chris will be able, who's pictured here, will be able to chime in. But we have seen that this is very doable from, and based on whatever experience you have. I think Chris had said it's kind of like building a Lego set, which I think is a great way to say it. So here's some of the more details on what that kind of looks like, right? Interpreting the bombs, identifying fasteners, using that rivet tool, and of course, always doing QC. I think everyone in this room knows how important that is. And we'd love to try to make it fun, right? Kind of a scavenger hunt. And the timing is really based on you. I think from soup to nuts, if you were just to work in one day, you could maybe knock it out in 1 or 2 days. But based on how you set up the curriculum, right, you might take weeks, maybe even up to a month, depending on your pace. And then Eric, if anyone hops in with questions, let me know because I actually can't see the chat box. So if you don't mind helping out with that, thanks. So on the autonomy side, students can customize and operate the platform. So this is everything from being able to turn on the system, doing basic vision and motion, oftentimes with cones or things like that to do line following. Then applying that vision, so with person following, and then doing more advanced things, again, based on your desires. So here's an example of what that can look like. I think it's something that only makes sense if you have this background, but our goal again is to educate you on this. Yeah, honestly, I have no clue what HSV masking is, so maybe Ahmed can educate us if he doesn't mind. The goal too for us is, integrate into CT goals and standards. We are still learning what this means. And so I want to be frank here, but talking to the teachers we have, example sectors are the manufacturing and product development, ag and natural resources, engineering and architecture. So here's an example that was able to walk through one of the teachers here around sort of pathway B and personal and group safety, electricity and wiring, plumbing systems, metal fabrication, and ag machinery and power systems. So definitely if you would like to incorporate this into your CTE goals and standards, just reach out to us, right? And we can figure out where and how it fits, unless it's very intuitive to you. But of course, we can work on it together. So the Farm Robotics Academy, just to flip through this on the third piece, what are the students going to do? So here's the basic specs of the system. You get this base robot, as you can see, with a track width of 29-30 inches. It can turn in place. We do a 0 to 5 mph speed, towing capacity of 800 pounds. And the battery is, an 8-hour lithium ion battery. All of that stuff stays pretty fixed. But what you get on top, right, the autonomy, safety, and the attachments is really where students can play. So that's everything from building a wheelbarrow attachment. Sounds easier than it is based on our experience. That's all I'll say. Trailer attachments, mowers, sprayers. You can put anything on top of this. We put skeletons. Next month, we're going to put Santa Claus. So like you can really play with this, and it's just based on the imagination of the teachers and students, you all here. The second piece is the autonomy. So whether it's following a row, following a person, you can enable that. If you're doing more advanced stuff, of course you can do that as well. So safety is going to be, I feel, pretty important to each of these. So the obstacle detection and then being able to switch on these emergency stop buttons. Those are the red buttons here. So that might be a priority, of course, and then communication based on Wi-Fi. And so our goal is to award student teams, up to $1,000. So what we would like is probably to award several awards that total 1,000 rather than one grand winner. but let's see what the kind of batch turns out to be, and we can go from there. And of course, it align with the rules and regulations you have around kind of prize acceptance. All of you know this, the Farm Robotics Challenge, defining and developing a real world use case. So defining that problem with their farm, defining technical objectives, designing test features, demonstrating in the field, and then submitting for the challenge. So here's an example. We're able to speak to it after Corey, but Ray might face challenges transporting crops. He might spend 25% of his day, using a trailer. So the technical objectives would be, what is the attachment? In this case, a trailer. What's the objective? It needs to haul up to 225 pounds for him. Even if it has more capacity, right? It's understanding what he needs. What kind of autonomy? Follow a person, right? Maybe it needs a remote control. So you want that sort of gaming remote. Obstacle detection, of course, and emergency stop we think should be pretty standard with a lot of this. So what could that look like in the real world? So here's Ray with that beautiful, epic background on his farm, hauling a steamer. Another example is row following robotic transport for veneers, so table grape workers who use wheelbarrows, but they want to follow rows. They want to be able to computer vision detect the rows and actually reduce their crop transport time and minimize worker strain. So what does that look like? It could look like something like this, where you're ensuring the autonomy can detect the vines, and it can work through that terrain. Beyond ag, and this is just last slides here. Again, you can use this for non-agricultural purposes, and we are a very practical team, so wanted to put these things here. We were talking to teachers who talked about, well, maybe school maintenance staff could use this to haul their tools or trash bins. Maybe you can attach some sort of bin or utility cart. It could follow a person. Maybe you could do things like campus route navigation, and make sure you detect and avoid students and staff. And then here's, I mentioned the skeleton robot. So this was at Fiera last month. So again, these are things that you could just play with for fun if you have time. So pricing is 12K. That's kind of the base price, but we are, we do flexible pricing based on need as well. But I'm going to stop talking. I think I've talked enough. So I'd love for Corey to chime in. So Corey, I think I'll ask a question to you. First tell us like who you are, what you teach, your background.
Yes, I'm Corey Mesa. I'm a shop teacher out in LeGrand. I don't know who told you fantastic. They must be lying to you, but that's not the adjective I would choose. But some of you guys that know me are smiling. But yeah, no, I joke all the time about you know what? Hold on, somebody just started calling me. Another ag teacher. Come on, Sam. Sorry about that. There we go. Sam Meredith calling me right now. Jeez, Sam. All right. There we go.
Yeah.
All right. Always, yeah. So we I teach a little bit of everything. I know a lot of shop teachers back in the day, you had to do woodworking, welding, electrical, kind of the whole nine. And nowadays, a lot of them are getting kind of siloed, and there's like specific welding teachers and specific engines teachers. And so I'm really, really proud to be a shop teacher through and through. I teach all the disciplines and all that jazz. So I know my video's gone. There we go. I'm back. In my mobile office in my truck. So we are looking to kind of take these robots and do a little bit of everything. Kids they saw the gather and they saw the two front tires, and already they're brainstorming, how can we put tracks on this thing, and how can we make it taller, and how can we, like, my kids are those typical shop rats that want to make everything bigger and badder and louder and shinier. So now let's do it with robots. So we're really excited. I don't see any limits, and I like the analogy you guys said about Legos. I have a whole Lego room at the house, and my favorite part about Legos is, yeah, there's those directions, but afterwards, then what? That's when you start building on and changing and manipulating and doing them in a bunch of different ways than even Lego had in mind. So that's what I think is the perfect analogy for you guys.
Cool. Um, Follow-up question. What feels like you mentioned them working on the mechanical side of it, so that maybe feels like the most fun challenge. How are they, do you know how they're feeling about the autonomy and like, is it nervousness or excitement?
Some of them are a little scared. They're like, it's gonna follow me around. It'll do that. And I'm like, yes, but like I've explained it. I was like, yeah, it kind of takes the picture of your legs, and then it wants to make sure that picture stays the same spec. So it's gonna follow you to make sure that picture looks the same in a layman's terms, right? And so they're like, oh, I don't want to take a picture of my leg. I said, it's not really taking a picture of your legs. It's just that's the way it works. And so they're kind of nervous about the coding side, but I mean, we can teach that, and like I know there's enough AI stuff that'll kind of teach that side. So I love that they're mechanically minded and they want to make all the parts and they want to do all this stuff. So it's very very intriguing, and I think they're kind of it's like antsy, not anxious so much, but like excited, anxious. Like you're the next one to go on the roller coaster, and it's going to be fine, but you're still kind of nervous, but you're excited. You want to jump in and do it. So
Oh, that's cool. Can you remind us how old they are?
high
Roughly.
school. So we're nine to 12. And I have a lot of repeat kids that'll, they're my TA, but they're in the class again. And us being such a small school, we pretty much have medical academy, like electives. They have art, and then everything else is under the ag umbrella. So they don't really have much place to go other than hanging out with us all day. Good
That's
problem to have.
And then for the FRC, is the plan for the class to come together to compete, or is it going to be a subset of the class?
A majority of the kids are coming from my advanced fabrication class, but I've opened it up to pretty much. I teach the engine side too, so I've said we might need some engines people. We might need some, depending on what we end up doing with it. Right? There's going to be some fab. I had some kids that are like, well, I really want to do it, but I don't know how to code. And I said, well, how is your welding skills? And they're like, well, I'm still learning. And I said, well, can you grind? Because we might need some grinders too. Like everybody could be a part of it, and we want, you know, you might not be the best welder, but if you can, honestly, if you can sweep, we'll use you. Like we can put anybody kind of in that realm and make everybody part of the team. So
That's awesome. Does anyone have questions for Corey in the audience as a teacher, or how he's thinking about the FRC? Don't be shy.
Corey, you're my hero.
I'm your hero.
Yeah. So I'm kind of on. So I'm Ryan Patterson. Turn my camera on here.
Oh, there,
There
we
I
go.
am. So I'm Ryan Patterson. I'm ag mechanics instructor here at Modesto Junior College. And Corey, I'm like your students. Like
Yeah,
the building part, we're all over it.
yeah.
The AI technology, all of that stuff, I have no idea. So we're gonna learn along the way. So we're all in it together. My students are like adults, and I think we're probably all in the same boat. So
hmm
exciting stuff.
Yeah, and actually, Suma, me and Ryan were talking yesterday. That tour that we went on was with Ryan. That was the college we went to. So kind of full circle. But yeah, no, for my background, like I said, is I'm the shop teacher, but I did 3D printing and kind of stuff like pre-COVID, and that was like my nerdy hobby that I couldn't do in school. And once tech started kind of creeping in on the ag side, I just started implementing it in class. I have 5 3D printers that are all personal that are in my shop right now. The lasers and the CNCs, like that kind of stuff, we've all started bringing in because I worked in industry and that's what I ran in industry. And it's one of those things that most of these skills that I have and these nerdy hobbies I got from paying attention to my ag class in high school. Actually, I've known Ryan since I was like 15, I think, 15 or 16 years old. So yeah, does it make you hurt a little bit? Sorry.
Making me feel old, man. Come on.
I won't do the math for you guys, but yeah, just meeting at an ag mechanics contest with like-minded people competing for the same kind of thing, and this feels just like that all over again. So I'm really excited to see what these kids can do in uncharted territory. So
I love it. It's super inspiring. I'd love to ask, because you guys mentioned like the autonomy side. So maybe Ege or Ahmed, would you guys mind chiming in? Like, how do you feel this will work with students who don't have that programming background? Um, what would be your take on that?
Yeah, I mean, obviously robotics is an extremely multidisciplinary field. You have mechanical engineering, you have electronics, you have software. With our system, we do have tools that let you, remote control it with your computer, do very simple scripting. And Corey mentioned, like the students can use ChatGPT or some AI tools to help them do basic scripts. And a lot of the software we've developed, especially for education, was to simplify and add layers of abstraction. So we have remote control tools and a graphical interface so you can toggle the inputs and outputs. So you can even just manually control it, attach some actuators. You don't even need to program it to convey what the robot's going to do. And then you can take ChatGPT and build like a small script to somewhat automate that. Or even if there are interested students, use Python or existing tools to learn principles of programming and adapt it. So there's multiple ways to use it. If someone is, interested in the more computer vision AI side of it, they can delve into that. But if you just want to have a platform to build things on and run little mechanisms on it, you're totally able to do it, and you can do it with no programming at all. It'll just be a bit more manual.
That's a great answer. So I think a big part of the ethos is like, let's meet you where you are. So we can make it as easy as possible if it's just here, take a snippet and run it, or for those who are probably going to end up majoring in computer science and really want to push that piece of the learning, they can do that. I see Blake asked a question. I just want to be cognizant of Ray's time because I know he had to go. Blake, do you mind if we answer that after Ray chats? Because I know he's driving. I just want to make sure that he speaks about his experience. Corey, thank you, and keep. I know you might have to pop up. So
Yeah,
really,
we got an FFA bowling meeting I got to go jump into right now.
yeah,
So
the
if you
kids,
guys
right?
have any questions, yeah, I can't really type on my thing right now, but I'll send an email out to Suma with my email. Or you can share my contact if you want to. You have it. So
Okay,
if they want to
that
get a
sounds
hold of me,
good.
most of them I see or I recognize, but I'll see you guys later. Take care.
All right, thanks, Corey. Appreciate it.
Yep.
All right, so Blake, I'm not ignoring you, I promise. But I would love to get Ray Ray on now. So Ray is in Tennessee. There you go. Put your camera on. So Ray, I think first thing, if you could introduce yourself, your farm, what you grow, before we dive into the gather.
Absolutely. Yep. Yep. So my name is Ray Tyler. I farm in West Tennessee in a small town called Selmer, Tennessee. We grow 52 weeks a year. We do primarily just vegetables. We don't really do any fruit at this moment. A lot of carrots, radishes, lettuce, tomatoes, peppers, cucumbers, a lot of herbs, microgreens, all that stuff. I actually have two farms. My home farm is 100% covered with small cat and high tunnels, and um, and then my second farm, which I just started, is a 2-acre farm, and we do primarily root vegetables there. So that's and so our rental farm is about to wrap up for the season, but our home farm in Selmer just keeps on going all winter long.
Awesome. And you just harvested carrots today, right?
We did a bunch of carrots today. Yep. So we just wrapped that up. Me and my boys, helpers. So it's been a busy week.
All right, fantastic. So first question or second question, I guess, for you is how do you use the Gather, the robot right now, and what's your experience been like?
Yeah. We with our rental farm, which is kind of where I thought I would use it the most. Because you have to walk with the machine and it's pretty far away from the shop, we did not like having to walk that far from our fields to the barn, because we have a 4-wheeler. But what we have found is that we found it a lot more useful in our small farm, because we do a lot more walking. We don't really have any motorized vehicles. It's just very close quarters. And so oftentimes we're taking 1 or 2 totes and we're carrying them to the pack shed. It may be 200 or 300 feet. So it's a lot less of a walk, where the other Whiteville farm, we're talking, 1,000 feet that we're having to walk. So what we're actually finding is that in our home farm in Selmer, we use these kind of small wagons that we just kind of pull with a few totes. So we found a lot more use with hooking up those wagons to the Gather robot, and we've also have really liked, because when we're going in, say if we harvest some herbs or micros, they're a lot more lighter weight, but the totes are fairly large that we have to carry. So we've been placing them on the Gather robot, and then that's, instead of carrying that to the pack shed 100, 200 feet away, it's just kind of following my team wherever they go. So we've been liking that a lot more. So we're definitely getting a lot more mileage out of it on our home farm, which was kind of surprising. But
Yeah.
my team is really enjoying having this kind of robot follow them around with various tools. So I definitely see, because it's a fairly small machine, and so it's a lot more agile in kind of tighter places.
That's really cool to hear. Was it hard for your team to get the system up and running? Like, how did that experience
Oh yeah,
feel?
that was very easy, very easy. So within, we also have some H2A workers from Mexico, and they were able to pick on it right away, immediately. They love it. So everybody pretty much on the team there in Selmer has really enjoyed using it.
It's great.
My Sarah, my farm manager, she's like, it's like a little puppy dog following you around everywhere.
That's great. Have you named it?
Yes, I have, but Sarah and Moises are primarily used that almost every day.
Okay. All right.
Yeah, yeah, it's great. It's great.
Yeah, we encourage people to name their robots.
Yes, yeah, yes. I think she did name it. I just can't remember what the name was.
Okay, so for all the student teams, that would be really fun if you guys each named your robot.
Yeah, yeah,
If you want, no
yeah.
pressure.
It's like your own personal pet that follows you around.
Yeah,
It's very
yeah.
obedient.
Yeah, and so just to clarify to folks on this call, so for Ray's system, we did the person following mode. We've developed the autonomy for row following, for example, like table grapes, orchards, things like that. But for his applications, we hadn't yet even seen the farm, so we're starting with the follow a person mode, and then the idea is over time, right, we can advance that autonomy, right? So follow a person is a great starting point in our opinion, when you're getting used to autonomy and autonomous systems. But you can always add, right, the row, point to point, etc. So just to think about that, even for the students, right? Like where do they want their starting point to be?
Yep.
Yeah. Does anybody have any questions for Ray? Curious, if you were to work with students, Ray, what would you love them to try to experiment with? Is it the mechanical side? Is it something on the autonomy side? Right, with the
Yeah,
existing system?
yeah. So I would say, if anything, pushing the limit on what this is capable of doing.
Mhm.
Kind of like what you mentioned earlier, just thinking outside the box, not in just agriculture, but what other context or fields can this be used at?
Mhm.
Think of what industry is out there.
Mhm.
I love that picture of that janitorial cart. Maybe it's, someone is cleaning windows or sweeping, and that thing just follows behind you with the trash can or whatever cleaning tools. I think there's a lot more use for this machine outside of agriculture, and I think that's where this can get really exciting, on just looking at what is possible.
Yeah, that's a great point. And I think we're just starting to understand that, which feels exciting. Like
Yeah.
the practicality, again, like year-round practicality, right? How are you using the
Yep.
system year-round, off season, on season, those type of things, which could be interesting.
Yep.
Does anyone want to chime in with a question for Ray?
Sima, I think this would be a good time to ask Ray the question from Blake.
Okay.
Blake asked Ray about says, my only question you guys have probably thought through is how does it perform on powdery dirt or sand? Do the tires, are they thick enough to spread the weight as well as will its tires dig in if we has a large load?
Great question. Uh, we've drug it across loose gravel that, with the trailer before. We've drug it through like a mud puddle as well. We're not heavy terrain, so I can't really answer the question of would it go uphill on a muddy slope. Um, but everywhere, pretty much, at least in our terrain, it's been able to handle wet, dry, wet grass. It's pretty versatile with at least our terrain that we've encountered so far. I don't know about sand. We don't really have sand here. Um, but it's done very, very well with our current conditions, rain or shine.
Excellent. Thank you.
Yeah. And I want to be upfront, right? Like this system isn't a tractor, right?
Right.
So if you have big
Right.
holes, right? If you have like it is not a tractor. We will build a bigger version of this, a bigger, something that is even more ruggedized, probably by next year, for certain types of specialty row crops, things like that. But yeah, I do want to underline like this is not a tractor. The tires are not tractor tires. So it is not gonna work in every single situation. I think sand might be, if it's deep dense sand, I think it might be tough. Maybe Ege, if you can speak to this, because we've had some experiences. I feel powdery dirt is fine. Actually, that
Yeah,
feels easy. But sand, I remember that off-season table grape that was like sand that was this thick, I think.
yeah.
Like,
So obviously it's a small robot. We do
yeah,
have pretty large tires for the size of the robot, and we have different, like you can attach your own tires if there's specific needs. It is a standard size. And we do offer kind of higher traction tractor tires. It does have a caster in the back, which is also for outdoors use, but if the environment is super silty or very loose sand, it probably won't be able to do it just because of the form factor of the robot. But it should operate fine in dirt or gravel, unless it's extremely loose.
yeah.
But there are some limitations to it, unfortunately, just because of the size and the shape of the robot. Uh,
Thanks, Blake. Yeah, and if any of you guys have concerns around like if it can operate in a certain terrain that you or your students are, then like just email or call, and then if we can see a picture, like maybe we can make an assessment there. Um, my take would be probably for the student use case and the competition. I think it should be sufficient. Like you're probably not going to run the competition when it's like pouring out mud, potholes, right? Like it will be a little bit, right, of a, it's not running all season long type of thing. So we can probably work around some of the issues, right, if you face that. But everyone in the ag industry understands the environment is unpredictable. So so we get that. Um, but yeah, but we have tested it in a bunch of scenarios as Ray said, and feel good about it, given the specifications, right? That is very clear to us, the ground clearance and the tires and everything. Any other questions? Um, I'm curious if the folks in this room, if you know what your student projects are going to be yet, or it's really just kind of day one on it and you'll figure it out by January. Yeah, I don't know if you're full name is Dalcorn, or if that's just
Oh,
an abbreviation.
Hi there, thanks. It's Dan Alcorn. This is my
Dan.
first time on the meeting. It's nice to see everybody. Put some faces to the emails, but yeah, we are kind of ground zero here. We're a small school and in California, and we're a little more focused on the drone side of things, trying to design or figure out some delivery systems, but open to all ideas. But we are starting from square one right here. The team is kind of together, the kids are together, and we know we want to do stuff, but a lot of it's preliminary. I mean, soldering practice, working with the 3D printer practice, designing pieces and parts, as well as, getting different payloads and stuff like that. But it's nice to see a little robot in action and hear the real world use of the farmer, and I'm just excited to be along. Thanks.
Thank you,
Glad
Dan.
to- We're glad to have you, sir.
Yeah. And we're definitely a proponent of you need so many different systems and tools, right, on a farm to work, right? And like the cool like aerial robotics will pair with sort of small ground robots and be doing the work together in the future, right? That is kind of the vision. And we believe humans will always be in the loop on farms. And robotics will be pretty collaborative, right, on farms forever. So but that's cool on the drone side.
I mean, maybe something as simple as, I'm sure they have it, but the drones when we're out there, they're always needing batteries, and that portable solar panel you have, maybe they can be, mounted with stuff just to keep them running hour after hour. But that's whatever. I'll be quiet now. But where we are in the beginning.
Yeah, yeah. Well, all these ideas are great. I mean, I think that's what we're excited by. We're not what we're finding, and even with how we built the system, it's farmers, growers, users telling us what they want to do with it. It's not we're not we're not the ideators, right? Our goal is to build and make it work, and help distribute and everything like that. But I think we're very excited for the students and the teams to sort of see what ideas they have.
I think our project I think the way the grant was structured, will be more Amiga based, but something with row crops, vegetable thinning. We're not quite sure exactly, but I guess we'll find out tomorrow when we finish putting our proposal together. But
Yeah.
yeah, we're kind of on the front edge too, to where the drawback of a junior college is that I see students for a semester. So at the high school, you have a couple year relationship, you get to know students, and the way that all works out, and it's a little bit different than teaching in the high school. So it'll be a exciting journey to kind of figure out how this is going to work. I know sounds like we got a lot of help, Eric and Mandy and everybody involved. So we're excited to get going, but kind of a little nervous probably at the same time. So
Yeah. We get that.
So to respond to that, Ryan, take it and just take a chunk, um, submit what you got when you get to the end. One of the things that we're talking to California Youth Ag Expo right now is letting the teams continue to go through until July 15th. As far as we want you to submit by May 1st, because that's when we have all the awards and everything prepared. But conversation with Ag Expo is that they want to do a second round of judging after people have had more time even to develop their projects. So it's pretty exciting.
Great.
So,
Wow.
Suma, do you have anything else you wanted to share with your team?
Yeah, I think just to close it out, right? We did have a student actually, it looks like he was tied up with teachers, but he had built the robot without a mechanical background. He's actually studying computer science, and so just wanted to share that experience of him being able to do it with some supervision from Ege and Ahmed. But then by the time he was building the second, third, fourth robots, he was just using line drawing. So just saying like this, again, the idea of this feeling feasible and fun, kind of translating on that. But yeah, don't want to take up too much more of your time. I think I dropped in a form here. It's just our purchase request form that helps us get organized, for those who want to commit. It is not a contract in any way. It's really just for us to get organized. So if feel free to grab that link, and or can follow up later. And I'll put my email and phone number here again. And don't hesitate to reach out. We can, get on a call at any time if you have further questions.
Awesome.
Yeah, but thank you, everyone. I really appreciate your time being here.
So we appreciate you, Suma, and being able to be involved with the Gather organization, because what you're providing for us is a platform that we can build on, and that's pretty exciting. So thinking about what Suma has, think about how you can use this on your projects that you have right now. Definitely proposals are coming in. We've got that, and thank you for the ones you have submitted. Uh, please try to get them in by tomorrow. And a key point on that is please make sure that you have a 1 to 2 sentence, very concise statement of your project. And the purpose of that is that they will be posted on the website. And the second statement that goes along with it is we know your projects will change. What you started with in your proposal is not likely to be what you end with for your final submission. So we understand that, and quite frankly, we expect it to change because that's just the nature of innovation.
Mhm.
But with that, I want to say thank you very much for everybody. Thank you, Suma, for participating today and with your team. And if you have no other questions, we'll sign out and go back to our other duties as needed.
Yeah, great. Sounds great. Thanks, everyone. Thanks, Eric and Kelly, for hosting it. And we'll talk to you all soon. Yeah.